The race is on to harness fusion on Earth. Whoever succeeds will change the future of mankind.
We have a clear path ahead of us, and it's based on engineering. That ecosystem in Europe for magnetic confinement fusion is objectively the strongest on the planet. We've never lived in a world where energy is abundant, fundamentally. We need to build hardware that really powers up our entire society.
The ultimate energy source of the future, right? Virtually unlimited.
No risk of Chernobyl.
The meltdown runaway is physically impossible.
American companies don't lead on this, then the jobs, the wealth won't develop here, they'll develop in China.
Germany's new nuclear fusion reactor shocks the entire industry.
Hey folks, today I'm with one of the founders of one of the most ambitious companies in Europe, PROXIMA Fusion, Francesco Sciotino. There's very few companies on this planet where it's safe to say if they actually work, they might create a whole industry. Not even only like create that industry, but change every industry around it. Is this fair to say?
It's absolutely fair to say. It really creates a different ecosystem once you have energy that is abundant, safe, clean.
And from my understanding, you're very hell-bent to make sure PROXIMA Fusion is this one company.
We're gonna do it. This is the first time that anyone shows a fusion design that actually matches both the criteria from physics and engineering, and that really has a path to commercial realization. And we decided to make it public, a description of all the systems to show their coherence and really not claim that this is a big deal, but actually show it. We have a clear path ahead of us, and it's based on engineering. And people that really want to break the way society works, break this energy scarcity that our society is used to. We've never lived in a world where energy is not abundant, fundamentally. Fusion can really fundamentally change the way we think about it. And committing a lifetime, committing the best work of your life to that mission, you can only do it with the right people.
So where are you at, and who are you?
I'm Jonathan, head of labs and one of the co-founders of PROXIMA Fusion. I'm an experimental physicist by training, and I worked at Wendelstein 7X, so the big experimental stellarator in Greifswald. And actually, the hall that we're standing in has the same floor size as the torus hall of the Wendelstein 7X. We have been mostly doing stellarator optimization so far, so this rather theoretical work, which was easy for us because with the initial founding team being mostly physicists, this was something that we could do with the laptops from day one. But in order to build a stellarator, we really need to get into hardware.
Like 1-2 years, here's like big machines, and you run like basically most of your hardware engineering experiments directly from here?
Yeah, I think so. What you can see here is a typical shape of the stellarator coils. This is really an interesting thing. It involves a lot of modern prototyping techniques. So we had this 3D printed metal parts here. One specific thing that we evaluated with this one is orienting the tapes that we wind into this. You can see here basically one of these superconducting tapes that really carry a lot of the current, that is oriented in a way that we can always wind it over a convex surface under tension.
So you're actually running current through the thing?
We're actually using this exactly to test how much the superconductor can carry. We submerged the whole thing for that in liquid nitrogen and then did the measurements there.
Nice.
A little bit of office space, some workbenches where we are really building up our in-house manufacturing capabilities at venture speed. We do want to make the most out of our academic partners, and in particular for the superconducting magnets, the Porchera Institute is a really valuable partner because they have all the liquid nitrogen set up, the high current power supplies already set up and ready to go, including the people who know how to run this.
The story of Proxima spinning out from the Max Planck Society is of realizing that we actually have the models to understand what's going on at this point. In 2022, W7X met all its design targets. This is one of the biggest demonstration that humanity has ever pulled off of optimizing numerically massive hardware, worth everyone having a look at what W7X looks like. It's really one of the greatest achievements of humankind. One of the directors of the Max Planck once said, it's science cast in steel. I think that's an amazing expression. Epic. Very epic. It really gives the feeling once you enter the torus hall, you get the feeling that we pulled off something. In fact, it actually gives us a view, we think, the clearest view to what a fusion power plant needs to look like. It's going to be safe. It's going to burn a little bit of heavy hydrogen. A spoonful of fusion fuel has as much energy as 13 tons of coal. The moment you think about that, you're like, wait, that actually is physically real? This is physics we know. This is not the bit that is in question, let's say. So if you can pull all these properties together, and you need a system that is stable, that can run as long as you want it, because we're talking about base load and load following energy supply. So complementing what renewables, solar, wind can do, this can really stabilize our energy system and change the way we think about not only which industries we can pull off. Because if you bring the cost of energy down, you enable a whole lot of other things. If you don't depend on expansion of the grid, which is a very expensive thing that we're trying to do, which is great. But fusion can really complement all of that with the infrastructure that we have today. But it requires that bit of R&D that the Max Planck Society has been a world leader in, and that now Proxima is trying to bring on a more engineering-focused path in collaboration with the Max Planck on the physics side.
There's still a huge research race, from my understanding, but it's also like a path to actual engineering and actual commercialization. Is this your thinking?
That's right. So the critical thing that changed really in 2022 is that now the topic of stellarators is really driven by engineering. So it's fundamental what's left. In 2022, the last physics drawback, the last blocker, you could say, has really come down. There was a publication that came out by Landerman and Poe, and then another one by Goodman and colleagues at the Max Planck. That really showed the physics, there will be physics research for 100 years. We totally have not figured out everything, but we have a clear basis that we can build on, and now it's a matter of execution. And execution in engineering is best executed in startups.
And it's a hybrid of like multiple areas of engineering, right? Like a good part here is AI engineering as well.
Fantastically multidisciplinary. We talk a lot about simulation-driven engineering.
Yes.
So we're much heavier in Proxima on software infrastructure and how to enable collecting data. And if you collect data in 2025, you can do a whole lot of things with AI. So there is a clear opportunity there that we are now harvesting in letting AI systems guide our designs.
So even like the magnetic ring itself, like the shape isn't just like a donut and we're done. It's a very complex flow, and like to optimize this kind of aspects, this is where AI and simulations come in.
Huge number of free parameters, and you can play with so much. But what we've done in the past was have physicists come do an optimization of the plasma, come to properties that seem convenient, and then telling engineers, now go build it. That's literally how we made W7X. And it's incredible the device came together at all with that kind of separation between physics and engineering. And that doesn't have to be in 2025. We can put physics and engineering and economics in one optimization framework. This has been the key investment that Proxima did from the early days. It's why we built such an elaborate software infrastructure. And if you bring them all together, you reduce the incoherence and you don't go ahead and start building and then find out, oh, I forgot that.
By the way, the last 20 tons, wrong.
Exactly. This is fundamentally nuclear energy. So it's nuclear fusion is a correct expression. We try not to highlight the nuclear bit to help people realize that this is a fundamentally different thing compared to fission, which is the kind of nuclear that we know already, that we have power plants with. People intuitively know in some sense. It's why you see in the sky, the sun is burning with fusion, all the stars. So much mass means that the forces holding it together are enormous at the center. That pushes particles to be very close, and that means they get hot. And that high temperature, we're looking at 10, 15 million degrees Celsius. That allows it in those conditions to do to run some fusion reactions. Now on Earth, we can't quite do that. We don't have that much mass, so we have to press particles together in some other way.
So I have this plasma at an insane heat. How do I create energy out of that?
So what you're trying to do here is take a gas made of heavy forms of hydrogen. You keep it within a magnetic bottle and you heat it up not to 10, 15 million degrees like in the sun, but actually to 100, 150.
Hotter.
More than 10 times hotter than the center of the sun.
150 million.
This we can do. It sounds funny the first time you hear it, but we do it in lots of experiments around the planet. There are various ways of getting it to those high temperatures. The simplest to understand and what Proxima really focuses on is microwaves. So imagine having lots of microwave ovens, but thousands of times more powerful, and at a certain frequency of waves, of electromagnetic waves, that resonates with the plasma. If you have this incredibly powerful microwave ovens, then you can actually get the plasma to rise in temperature. This again is something that we can deal with. We have these microwave ovens, we call them gyrotrons. And if you look at Wendelstein Siebenex, W7X for short, in northern Germany is already using these kind of microwave ovens and has shown the kind of confinement that is needed. The concept is understood. This device runs for minutes, for 30 minutes at a time.
So it's stable, is this fair to say?
It's stable. It's a kind of stellarator, kind of magnetic. You can think of it as a donut with magnets that can confine the plasma in a stable way. And that is the path, we believe, to a fusion power plant.
And this is a stellarator.
This is a stellarator of a specific kind,
Okay.
which is labeled as a QI stellarator.
Technology readiness, okay? There's like all this TRI index and all this kind of stuff. How do you personally think of like time scale here?
It's really valuable to recognize that we're really building on research that has gone on for more than 6 decades, and that an organization like the Max Planck has really made this all possible.
Let's jump into this a bit. It all comes out of the quantum mechanics plasma area of Max Planck, as far as I understood.
The Max Planck Institute that we're referring to is the Institute for Plasma Physics,
Plasma physics, yeah.
which is more than 1,000 people between Munich and Greifswald, which is a town in the north of Germany, completely publicly funded. People that have already committed much of their lifetime to fusion, and now they're seeing a transition. And our Max Planck colleagues we still need them to keep working on W7X, which is amazing stuff coming out. There are some really exciting announcements coming out of W7X as well. The physics needs to keep evolving. So there is still definitely a space where we need public research to keep delivering. But we are in this
because
space
it's
where we
so
can
far
actually,
on the edge. Like it's so on the edge that there's...
Right, we're definitely at the space. If we don't think as an ecosystem, that ecosystem in Europe for magnetic confinement fusion is objectively the strongest on the planet. Knowing that W7X is out there and operates for 30 minutes and it's stable, if we hadn't seen it, we couldn't claim that the TRL is very high. You need to have a first of a kind in the 2030s. To have a first of a kind in the, say, mid-second half of the 2030s, you need to have a demonstration of net energy production in steady state, meaning the PROXIMA roadmap is to bring that device net energy in steady state in 2030.
So like just to explain this term, net energy in this case means more energy comes out than you put in. Is this fair to say?
Which is not a fundamental, there is no, oftentimes I hear people saying the real problem with fusion is making more energy out than in. You're like, well, that's a trivial statement, but there is nothing really that happens at that transition of more energy out than in. It's a psychological barrier, you could say. We know that can be done. The real question that is ahead of fusion is economic viability. And
Interesting.
PROXIMA has done a whole lot of work, and we're about to make some very exciting announcement on the coherence of a design, of a fusion power plant design that meets the physics criteria, the engineering criteria, and there is work happening on, we believe that concept has the path to economic viability, which means also knowing what kind of R&D needs to be done, knowing that it's feasible, knowing that we can pull it off. And that's the place where Europe can really punch above. We're targeting results, looking at the net zero ambition of 2050, let's say. If you want to fix that energy, carbon emissions related to energy, by that time scale, you need to think about thousands of power plants.
Smaller startups you talk to, they think in like 2-3 year horizons. Your point of view is kind of like if you want to create a generational defining technology, you need to put like a generation behind it. What changed for you when you switched from like, hey, I'm researching something really exciting to like, this is actually possible? Might as well, because this could be the biggest thing ever.
You need to be a little radical in some ways. I've been in fusion for some time, also in my research, and the commitment to get this off the ground has been with me, with some of the team members of PROXIMA for quite some time. We do some of the best science on the planet, but we don't create companies.
Yes.
And this is kind of a mindset that we got to change because we need to actually compete.
But the problem that we have is, and I think that a lot of people in Europe do not understand the magnitude of essentially power law in business nowadays. Like if you are the number one in an industry, there's a high chance that you conquer 80% of the market nowadays. But there's like multiple fields where there's like 1 or 2 companies that dominate the whole market. The fact that when you have these really, really large companies, like for example, the biggest 7 in the US, their R&D spending together is as big as all the VC spending in the world. Their investments in startups is as big as all VC spending in Europe. These companies spawn whole ecosystems around them, you know what I mean?
And I think if those companies have outrageous ambition of doing something that is not only world-class, but also objectively pushing technology, various technologies to a higher level. That's the kind of ecosystem powering up that we really need in Europe. So we are lacking those lighthouse projects that get the best people from Europe, but also Europeans from the US, but also
or Americans.
Also colleagues from the US who see the best approach. They see the team that they want to learn from, they see the right partnerships, and they see the right opportunity. We're not exactly doing great in energy, in clean energy supply in Germany and Europe overall, So this is clearly a topic where Europe cannot miss the ball. Also, fusion is the kind of space where I believe there will be multiple leading players. It will get more and more geopolitical. There will be an Airbus of Europe, there will be a Boeing of the US, and a Comac of China. We can expect fusion giants to be developed in each geography. We cannot miss the boat on this one. First, we need to leverage our strengths. It makes for a compelling case of also independence of sovereignty on energy.
Yes.
But it's also an
Which is a very good topic now.
We build on that to then say, this is a technology where we can actually lead. Let's go and actually compete with the guys on the outside in fair, good competition.
Be the number one, period. So you're publicizing basically your roadmap and how the whole thing comes together. And I assume to make it credible to the scientific world, you also need to show like a few like approaches, breakthroughs, and like how things fit together. How does in this, people maybe not perceive it at that yet, but like very soon hyper-competitive field of fusion energy, where the states have like twice the amount, if not more, of the startups that Europe, for example, has. And all kinds of countries are now like having their own fusion energy startups. And yes, it's compounding and you learn from each other, but to some extent it's also like hyper competitive and like only, you mentioned before, like there will be a Boeing, there will be an Airbus, but there won't be like 50 Boeings, you know what I mean? How do you handle, like what do you share publicly compared to academia where it's very common to share everything public? How do you share like this, like public versus non-public, collaboration versus like magic sauce?
Great question.
Like, how do you handle that?
So we have a very clear motto there, which is open science, close engineering.
Nice.
Our partnerships are on the scientific side. So the Max Planck Society is our key partner, and it's one of the strongest institutions on the plasma physics
in the world.
PROXIMA is an engineering company. And on the engineering side is where we're creating the intellectual property, which will be at the basis of this new industry that is now taking shape. So open source software is very important to us, and we're taking very important steps on that at these times. On the engineering side, of course, we will not publicly discuss the way we're making magnets, but we will show milestones and we will make sure that people can tell the difference when some things are demonstrated, like now with the Stellaris stellarator design there. That's one moment where we realize that this is such an important step that it needs to be actually not only shown publicly, but it needs to be validated. That's the peer review process. It needs to be known and clear to everyone that things have changed.
If you would have one free wish from the European Commission to 10x your industry, not even just Proxima Fusion, but your whole industry, what would that be?
First, there needs to be clarity about the fact that we need to do big things, that we won't get away with looking for giants that are startups that sell commercial software or that provides various kinds of services. We need to build hardware that really powers up our entire society. We need to look for those lighthouse projects that inspire people to really say, Europe is not quite dead yet. We can actually go and compete with our American friends. We can totally stand up to Chinese colleagues who are also very ambitious. We need to have the European Union saying out loud, we will support this stuff. It's not just a matter of money. It's not just a matter of speeches. It's a matter of building up the ecosystem and telling people, we will support this.
And it's okay to have ambition.
It's okay to have ambition. Mario Draghi once said it at the time of the financial crisis, we will do whatever it takes.
Appreciate it. Thanks so much for your time.
Thanks, Andreas.
Cool, this was Proxima Fusion. Thanks for watching and see you soon.